Hey guys, Mr. Wiz here. We got an important lesson for you all today. Today we're going to be looking at logic and conditions. We're also going to use them in some programs that we've already made to make those games even better. So what is logic? Basically, logic is a statement that says if something is true, then something else will happen. We've used logic and conditions all the time in our normal conversations that we might have. For instance, you might tell someone, if the brownies are done, take them out of the oven. That's a pretty normal, logical statement. We know in that statement that we take the brownies out of the oven when? Well, if they're done cooking, right? So that's the idea, and computers programs run off of logic all the time. Pretty much everything they do is based on these logic and conditions. In fact, we've already been using them, even though we haven't talked about it. What I want you guys to do, first off, of course, make sure you are signed in. See your initials or picture in that top right corner. And if you are, I want you to hop over to the asteroid program that we've been making in the last few videos, because we're going to make some changes to it. But before we make changes to it, let's talk about what it already has. So the onStart block is a very important block that occurs when the game starts, right? Think about what I just said. When do these actions occur? When the game starts. That is a condition. Basically, we could reword that as, if the game starts, then do these actions. That is a type of condition. If it starts, do these actions. Or you might say, when it starts, do these actions, right? So that's a type of condition that's already been occurring. The button presses that we did earlier, where when I press the A button, it shoots a laser. We could reword that as a condition. If the A button is pressed, then shoot the laser. So an on A button press block is a type of condition. It's saying, when do we do the actions? We do the actions when the button's pressed. The overlap code here for when the blaster overlaps with a projectile, that's a condition. When do these actions occur inside here? They occur when the blaster overlaps with the projectile, or if the blaster overlaps with the projectile. All of these blocks are essentially conditions. On game update, when do these actions occur? They occur when the game updates every second. When do these actions occur? This action occurs when the player overlaps with the projectile. And this action occurs when the projectile is destroyed. So these are all conditions. The basic idea is when an action is occurring, we need a series of responses, right? So if this happens, then do this. That's how the computer functions. Everything we've told all of these programs that we built so far is based on conditions. We're telling it, when this thing happens, do this. Or if this thing happens, do that. Sometimes we don't have enough blocks, though, that are pre-built like the ones we've been using. Sometimes you have to create your own, and that's what we're going to be doing now. So to create our own conditions, rather than using these pre-made blocks like what we have already been using, to create your own conditions, you go to the section over here on the left-hand side that says Logic. And here we have the conditionals. If true, then. So this block fits inside of actions that we already have. So normally we would put it inside of one of these other blocks, but if there's not one that works for you, you can put it inside of just a basic on-game update, right? So if you put it inside of an on-game update, then that logic will run constantly. Otherwise, you put it inside the block that it makes the most sense to run it in. So if something is true, then do something else. That's the basic idea. So what we're going to do here is I'm going to use this. Let me shrink my picture again. I'm going to use a condition to make my game get harder as I play it. So right now, when I play my game, it's not that hard. I'm shooting at the asteroids. I'm trying to avoid them. Everything's great there. And I'm getting points every time I destroy an asteroid, right? But let's say that I want to make this game get more challenging as I play it, because right now it's actually a pretty easy game. So let's go ahead and create a condition that makes the game harder as I get more points. So this part right here, on game update every 1000, is what's creating the asteroids, and it's also setting their speed. So what I want to do is make the game where the speed gets harder as I play. So instead of using this random, just to make our code a little simpler, let's just go ahead and leave it at -50 for now. So at the beginning of the game, my asteroids will all start with a speed of 50 pixels per second to the left. And then I want it to get harder when I get to a certain number of points. Just for the sake of this, we're going to keep it simple. We're going to use 10 points for when it gets harder, okay? Let me move some of these blocks I'm not using right now out of the way. So inside of my on-game update, I'm putting an if-then statement. And then inside here where it says true, this little hexagon diamond-shaped thing, this is where I would put my condition. So I need to ask myself, what do I want to be true? Now, I already mentioned it, but let me see if you caught it. I said that I want the game to get harder when I reach 10 points. So what is the condition that needs to be true before the game gets harder? I need in here the if statement, the condition, to be when the score is 10 or greater, right? So how do I do that? So in these code blocks over here, anything that you see that is diamond shaped, like this hexagon diamond here, that will be able to be used as a condition. So if you scroll through these, you'll see a couple of them. Here's a condition for overlap codes. In the controller section, there's a condition for when buttons are pressed. Anything you see that is that diamond shape, you can use in a logic block. So what I'm going to do is I'm going to go down here to logic, and I'm going to use the comparison blocks. So comparison is the basic idea behind most conditions and most logic is a simple comparison. Remember a while back I told you that computer programs are basically just constantly calculating things. That's why computers are called computers, because they're computing mathematics. That's the idea here. All of our program is built on logic, and it's done by comparing different quantities. So we're going to use this comparison block here. If, and what is the thing I'm comparing? I'm comparing the score. So I'm going to go over here to info, and I'm going to grab this circle that just says score. So if the score, and I'm going to put 10 here. Now, do I want it to be equal to 10? Do I only want the asteroids to move faster when the score is exactly 10? No, I want it to be 10 or higher, right? So in here, I have different options. I have equal, I have does not equal, I have less than or equal to, greater than or equal to. I'm sorry, that was just greater than, and this one is greater than or equal to. Let me zoom in a little bit in case you can't see it on the size of your screen. I want to make sure you can see these drop-down options. This is kind of small. All right. Boy, even when I zoom in, it's small. But yes, equal, does not equal, less than or equal to, greater than or equal to. So in this case, I want the game to get harder when it's greater than or equal to 10. If I just put equal to 10, it will only happen one time. But I want it to continue to be harder as the game progresses. Let me zoom back out now. Okay. So when the score is greater than or equal to 10, we're going to change the speed of this asteroid. So I'm going to go down here and I'm going to set the asteroid Vx, velocity x. So it was -50. We're going to make the game get harder. So let's change it to -70. So when the score is greater than 10, they're going to increase their speed from 50 to 70. I'm keeping the negatives because I still want them moving left, right? So let's go ahead and test out the game, see if that worked. So what we should notice is at the beginning, they're moving 50 pixels per second. Pretty simple. I actually won't shoot them here because I want to see the difference. Once it hits 10 points, we should notice they get faster. And here we go. You see how these are a little bit faster than the other ones? Great. So our condition worked. Our condition worked exactly the way we wanted it to. All right. So that's a simple condition, an if-then statement. Here we have a condition. If the score is greater than 10, then do these actions, right? Okay, so what if we have more than one condition? What if I want the game to keep on getting harder? What if I don't want it to just have this one difficulty? Well, actually, it has two difficulties right now, right? So it's -50 and then it has -70. What if I want it to keep getting harder? I can add more logic blocks. Let's say if it's greater than or equal to 20. Then I'll make the speed go up to 90. All right, so I can keep doing this, and I can create more and more and more of these. But sometimes you don't want to do that. Sometimes you don't want to do that. Sometimes, instead of having multiple logic blocks, you actually want to have combined blocks where they're both one block. So let's just check right now first and see if this works the way we want it to. So we're going to go ahead and get up to 10 points. All right, so here we go. They're now a little bit faster. Good. And if I get up to 20 points, it should get even more quick. Yep, there we go. Now they're even faster again. Cool, cool, cool. Okay, so this is working. And this is working actually pretty decently, not going to lie. But there are other ways that we could have done it, where we actually had one block for all of our speeds. So I'm just going to save it right now because I'm about to make some big changes to my code. And whenever you make changes to your code, especially if it's already working, it's always a good idea to save it just in case you end up breaking something, right? So here's what I want to do. Instead of basing it on greater than, what if I had written my code and based it on less than? What if I had done this a little bit differently? So let's say when it's less than or equal to 10, it's going to be going 50. If it's less than or equal to 20, then it's going to be going to 70. Let's do another one where if it's less than or equal to 30, then I go up to 90. Now this might seem like pretty much the same code we had before because it's the same speeds. We still have it going 50 at its first difficulty, 70 at its second difficulty, and 90 at its third difficulty. But I'm going to let you in on a little secret. This is not going to work. Let me show you. It looks very similar to the code we made before, but it's got one big problem. So let's go ahead and play it. It's immediately going at the higher speed. You might not be able to tell very quick, but watch when it gets to 10 that it's not going to speed up at all. It's already at the 90 speed. In fact, just to make sure it's more obvious, let's change this to a higher number that's a little bit quicker. Let's say the top speed is 200. You see how it's immediately starting at the top speed? So why do you think that's happening? Look at the code here. Why do you think it's ignoring these first two and jumping straight to the last one? Think about the way a computer works. It reads line by line, right? So as the computer is reading this code, the first thing it does is it creates the asteroid and sets its speed because we told it to. Second thing it does is it sets the asteroid's position. Third thing it does is it checks this. So score is less than 10. Well, at the beginning of the game, it is less than 10. So it sets the asteroid speed again. All right, cool. Then it goes down here. Is it less than 20? Well, 0 and 1 are less than 10, but they're also less than 20. You guys following me? Those first couple of numbers that are less than 10 are also less than 20. And then down here, if it's less than or equal to 30, well, all the numbers that are less than 10, guess what? They're also less than 30. So what happens is it actually changes the asteroid speed multiple times. When it creates the asteroid, it sets it to negative 50. When it reads this logic block, it sets it to negative 50. When it reads this logic block, it sets it to negative 70. When it reads this logic block, it's setting it to negative 200 because that's what I put there. So it's doing this all instantaneously, which means that immediately it's shooting a 20 pixel per second asteroid. So how do we keep this from happening? How do we prevent it from skipping these two and jumping straight to that one? A couple different ways we could do this. So one thing we could do is we could add some Boolean objects to our condition. So Boolean means that you have more than one condition typically, right? So in the real world, if I think of a Boolean logic scenario, I could say if the brownies are done and the oven's still on, then turn off the oven. Now I have two conditions. The brownies need to be finished being cooked and the oven needs to still be on. Now we take them out and we turn off the oven, right? So that's the idea here. With these and or blocks, you can have more than one condition. With an and condition, they both have to be true. With an or condition, only one needs to be true. So that's an important distinction with logic. If I said, if the brownies are done and the oven is on, that's an and. Both have to be true before I do the action. If instead I said, if the brownies are done or there's smoke coming out of the oven, then turn it off. Now that's an or statement. So the brownies are done or there's smoke coming out of the oven, right? That's an or. I will turn off the oven if the brownies are done or if there's smoke. It doesn't have to both be true. So and means they both need to be true, or means only one needs to be true. So one way we could fix this problem from happening would be to add some ands. So I could put, I didn't mean to do that. Let me put this in here. You gotta be careful when you're dragging and dropping this stuff. It's a little bit tricky. So if the score is less than or equal to 10 and the score is greater than or equal to 0. So now it's a more enclosed space. Now this is only true with numbers, I should put greater or equal. Now this is only true for numbers between 0 and 10. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? And if I did the same thing to these other ones here, I could make this for numbers less than or equal to 20, but greater than or equal to, actually, let's just do greater than, because I don't want to do equal to since I have equal to up before. Greater than 10. So now numbers 11, 12, 13, 14, 15, 16, 17, 18, 19, and 20 will all affect this one. And I could duplicate it again for this section and use 30 and greater than 20. So this is one way that I could fix that problem that I ran into. Here's the fun thing about coding. There is almost always more than one way to fix a problem, though. So this is one way. Let's just test it out, but I'm pretty sure it's going to work. So with this and conditions, okay, it's back to being slow. Good. Let's see if it gets faster when I get to 10 points. Here we go. I'll just let it happen. Yep, there we go. There's the faster one down there. Okay, and then when I get to 20, it should get faster again. Oop, and there's my super fast ones. Yep. So that worked perfectly fine, but this is not the only way to do it, okay? So this would be one way to do it if you have multiple condition blocks that are interacting with each other, that are kind of affecting each other. You can make them more specific by using and blocks to help narrow down the criteria. All right, let's do it a different way. I'm not going to use the and block. I'm also not going to use multiple logic blocks. Here's the way that I like to do it. Oops, I shouldn't have deleted all those. Let me get one of them back. All right, so the first one was for the score is less than or equal to 10. It's going that speed. So rather than adding multiple logic blocks, here's how I'm going to do it. I'm going to do it with this little plus sign right here. With the plus sign, I can add multiple conditions in order. And here's the benefit of doing that. If I have multiple conditions that are all part of the same block, notice these are not different blocks. These are all one if block. If I have multiple conditions in the same if block, the computer reads them one at a time and stops as soon as it gets to one that is true. It doesn't read any further. So right here it says if the score is less than or equal to 10, set the velocity to negative 50. So that means when the score is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10, it will do this. If the number is greater than 10, it's going to go to the next condition. So for the next condition, I'm going to put less than or equal to 20. Then I'm going to put another condition for less than or equal to 30. And I can do this for multiple conditions. We'll do 40. We'll do 50 here. And then for these, I'll just make each one a little bit faster like we did before. So we'll go 70. 90. I'm just duplicating each one and making small changes to it. 110. I'm increasing by 20 each time. Of course, for your own game, you can decide what numbers you like. We'll do 130 there. Okay. So I've got a great little setup here. When it first creates the asteroid, it has a speed of negative 50, and then it gets to the logic, and it starts reading these logic blocks. If the score is less than 10, set the speed for 50, or negative 50. These are all negative because we're moving left. If the score is not less than or equal to 10, that is when it reads the next line. So even though this looks a lot like what we had a few minutes ago, the important distinction is this is all one block. This is all one logic block. So even though 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 are all less than 10, but they're also less than 20, and they're also less than 30, and they're also less than 40, the computer does not read these logics unless the first one is not true. So first thing it's checking is it less than 10? Yes, it is. It will do this action, and it will ignore everything else. If it's not less than 10, it will read the next one. If this is true, then it will do this action and ignore everything else. Does that make sense? So let's just test this real quick so you can see what I'm talking about. It's all one logic block, but if I did this correctly, the first part here has a speed of 50. And it looks like it's working pretty good. They're nice and slow. Here we come. And wait. Oh, there we go. Those are faster. That seemed like it took a second. But yeah, there we go. And now we're getting to 21 where it should get harder again. Yep, there we go. Those are a little bit faster. And then if we get to 30 or 31, it should get harder again. I can't tell if it sped up or not. I think it did. Oh yeah, they're definitely still getting faster. Look at that. And then when it gets to 50, I want you guys to watch something crazy that's going to happen here. It looks like my program worked the way I wanted to. But watch what happens when it gets to 51. They all got slow again. Why do you suppose that happened? Look at the blocks that I have here. Look at the logics that we've created. If it's less than 10, do this. Or else, if it's less than 20, do this. Or else, if it's less than 30, do this. Or else, if it's less than 40, do this. Or else, if it's less than 50, do this. We didn't tell it what to do if it's greater than 50. You following me? We never told it what to do when it's greater than 50. So what does that mean? That means it did nothing. It made no changes. Up here, the asteroid was created at negative 50. So since it made no changes, it just left it at negative 50. So the last block in our chain does not say else if. It just says else. What does that mean? Else means if nothing above it is true, then do this. So let me create a real-world scenario for you. Let's go back to the brownies. If the brownies are done cooking, take them out of the oven, or else leave them in the oven. So else doesn't need a condition. Did you guys catch that? I didn't say or else if. It's just else. So anything that is not true, if nothing above it is true, then do the else. Let me think if I can come up with a better example. If it's sunny outside, I will walk the dog. Or else, if it is rainy outside, I will watch a movie. Or else, I will play a game. Did you catch all that? Let me say it one more time. If it's sunny outside, I will walk the dog. Or else, if it's rainy outside, I will watch a movie. Or else, I will play video games. So my first condition was if it's sunny. What action am I going to take if it's sunny? I'm walking the dog. Then I have an else if for if it's raining. What am I doing if it's raining? Well, according to that scenario, I'm going to be watching a movie. And then at the end, I just put else. I didn't give an else if. I just said else. So if it's not sunny and if it's not raining, what am I going to be doing? You know from that statement, I'm going to be playing video games. It could be cloudy outside. It could be snowing outside. It could be anything other than sunny and raining. Any other thing that's happening, and I'm playing video games based on my statement. So that's the idea of else. Else means that everything above it is not true. So in our scenario, if it's less than 10, it goes that speed. Between 10 and 20, it's going to do that speed. Between 20 and 30, it's going to do that speed. Between 30 and 40, it's going to do that speed. Between 40 and 50, it's going to do that speed. Or else, so this is anything greater than 50, I'm going to make it a higher speed of 150. So now it will not slow down once it gets greater than 50. It will just go to its max speed, which will be 150 in this scenario. Now, here's the cool thing about this. I can have as many logics as I want to. I just stopped because I felt like stopping. I could have kept hitting that plus sign and kept on adding more and more and more conditions if I wanted to. So I could have a game that continually gets harder. Instead of having 5 levels of difficulty, which I think is what I came up with, it could have 10, 20, 30 levels of difficulty. There's no limit to how many else ifs you can put inside of one logic statement. So right now, I have a game that is progressively getting harder. This is pretty fun. So I'm about to get to 40. There we go. And then once it gets up past 50, I'm going to be on my final difficulty level, and it won't get any harder after that, based on the way that I have coded it. There we go. And now they're at 150, and that is as hard as this game is going to get based on the way that I coded it. But they did not slow back down like they were before. Okay, I know that was a lot to absorb in this video, but the big important takeaway is that logic blocks can be used pretty much anywhere you want to put them in your video game. So anytime you want something to happen in your game when a certain thing is occurring, just reword it in your brain as logic, right? So I have students that will ask me, hey, how do I make it so that when the bad guy's health gets lower, he changes his attack? Well, I'll say, what does that sound like to you? Let's reword that. If his health, which is going to be a variable, is less than a certain amount, then you do something. That's a logic block. If, then. If, then. So when you're thinking about things in your game, almost anything, you can do almost anything in a game. This is really where you get to be really creative with it. You can do almost anything in a game if you can figure out how to reword that as a logic scenario. If something, then what, right? If the player's health is low, then what? Or for the end of a game, you can have multiple different endings where you could say when the game ends, if the player's score is greater than 100, then this happens. But if the player's score is less than 100, then this happens, right? So if, then, almost anything you can imagine, you can create in your code using if-then logic. I hope this video was helpful. If you learned something new today, please make sure that you hit that like button. If you're not already subscribed, please subscribe. And I cannot wait to see you in the next video. If you made something cool now that you learned how to use logic, please share that game with me by hitting the share button up here. Hit the share project, copy that link, and put it in the comments so I can see what games you made with your logic blocks. Until next time, I hope you have a great rest of your day.